Well, XHR2 is nothing other than XHR that was already there. XHR already had some of the basic methods, some of the basic objects that was required, and along with these, XHR2 came up with its own implementation, with its own specifications that were now used to get around the specification of same origin policy. So in a way, we can call that it was an extended version of the XHR, right? Okay, so I don't think we'll have time for the demo for this. Okay, so we cannot share any. Okay, so some of the important things to note about cross-origin resource sharing is that that whenever we frame a particular XHR2 request, it will always contain the origin header. So basically what you do is, when you create an XHR2 request, you use some of the native methods that are there in XHR2 that are allowed by XHR2. So with XHR, you already had the XHR.open, you already had the XHR.send. So with the open method, you would have the HTTP method that you want to pass as a parameter, the URL that you want to access as a parameter, and the asynchronous mode that you would want, the sync or the async mode that you want to pass as the parameter. These things will always be there as a part, were already there as a part of the XHR specification of the open method. And then after creating the request, you just send it over. The same thing happens with XHR2 as well. The difference being you have some added features into the course feature. The difference being you have some of the added features into the course feature. So whenever you send a particular request for XHR, the most important header that gets sent along with the other general HTTP request headers is the origin header. The origin header is actually what determines from which particular origin domain is the request coming. So if you would look at a sample XHR2 request, it would have the get header, and then you have the origin header, which specifies the domain from which the request is originating. It will have the host, that is the the domain for which the request has been made, and then you'll have the general all the other, like except language, connection, user agent, and all those other request headers. On the server side, on the other hand, when this particular request is to be handled, and if the server side is wants to support the cross-origin the CORS2 feature, it will have to introduce an additional response header, so that it understands that it is also supporting XHR. So one of the most important response headers that the host domain will be having for supporting it would be access control allow origin. Now, as the name suggests, access control allow origin, what it says is, for a particular domain is allowed to access a particular some other domain. Let's say, so in our example, when we are talking of domain1.com and domain2.com, now we saw that same origin policy was restricting the scripts on domain1.com to access domain2.com, or the characteristics of domain2.com, the elements on domain2.com. If at all domain2.com wants to support XHR2, what it will do is, whenever there is a request, it will always have in its response headers, it will always have the header called access control allow origin, in which it will say domain1.com is allowed. So whenever a request comes from domain1.com for any of the features on domain2.com, it will be allowed because that has been allowed by the response headers of domain2.com. Now that is what happens when a particular domain would want to support XHR2, right? But then, and that is how you would use HTML5 to bypass the same origin policy. But then the most important part, so as you can see over here, yeah, I'm sorry, I didn't switch the slide. So yeah, here you see access control allow origin. So if I say api.bob.com, it means that I'm allowing api.bob.com to come and access my the properties of my domain, which could be alice.com. So that's how we allow it. And then there are other headers as well that say access control allow credentials, which is the case when we would want to use cookies and all of those authentication stuff. And then we have control expose headers. So whatever headers, whatever the part of the header that we would want to expose. So these are the different features that will be implemented by XHR2 response. Now, the security part of it, where does security kick into all of this? So the very obvious question that arises after seeing that same origin policy can be now bypassed in a very standard fashion is that what if any domain is allowed to access any domain? In that case, there is no question of security at all. Same origin policy has been bypassed, HTML5 has been introduced, and with XHR2, with cross-origin resource sharing in place, so everything seems like it's all going to be a security flaw, a huge security flaw in the specification itself. Well, that is not what the situation is. That's not what the case is, because it always again depends on how responsibly we are going to use these features. So let's say if instead of allowing access control allow origin, instead of mentioning a specific domain in this particular response header, if you mention a star over there, which means any domain is allowed to access the contents on my page. That could be the case for some of the situations, for some of the use cases where it is actually required, but then leaving a star over there just as a fault or without proper understanding of the entire application would be a huge mistake, because then any application would be able to understand any domain in the world would be able to access the contents on your domain, which would not really be recommended. Similarly, there are other there are other important features as well for these response headers that should be taken care of. For example, whatever scripts that are being allowed, there should always be a URL encoding for that, so that you should not be depending on this. You should not be solely depending on the response headers to take care of the security of it. Moving on to the next slide. Okay, so this was a very theoretical description of what and how what could be an irresponsible use of the HTML5 CORS feature. But apart from this, if a real world working scenario or real world working tool is required to understand the impact of this particular thing, I would recommend the reverse web shell, which is used to, which if you use the reverse web shell, you can actually get hold of the entire user's session. You can get hold of the entire user's browsing session from your domain. So what basically happens in a reverse web shell, which makes use of the XHR2 feature, or rather the CORS feature as we call it, of HTML5, is something of this sort. So let's say, for example, on a particular domain, let's say, for example, on say domain1.com has got a certain vulnerability in it. Let's say it has got XSS vulnerability in it. So what XSS means is cross-site scripting. What exactly cross-site scripting is? You can enter something. You can enter your scripts in place of the normal inputs that should be going into the page, and whatever input you give, it is actually malicious. Let's say for example, on a particular page, you've got a search box, and you can search for different things on that particular page. And instead of pushing in simple strings as search terms, what you push in over there is, let's say, a script tag with some malicious script in it, with some script to, let's say, steal the user's cookies in. And what happens is, when you click on the go button after pushing it in the search box, this entire query goes to the web server, and in case there is no validation done on this particular input from the user, it simply gets reflected back from the web browser, from the web server onto the web browser, and it gets rendered by the web browser. Now, since the user had pushed in some sort of a script and not actually strings, this entire script gets reflected back and rendered and it gets executed in the browser. Now the script could be doing anything, as I mentioned. It could be even stealing your cookies. It could be stealing your session. It could be doing anything. So this is what an XSS would be. A classical reflected XSS would be. Cross-site scripting attack would look like. Now, if, for example, I have got an attacker site, let's say attackersite.com, and I happen to find a particular, let's say Facebook has got an XSS. Facebook actually does not have an XSS. Let's just say, for example, Facebook has got an XSS. You are already browsing some Facebook session, your Facebook session, and I happen to lure you to click onto my attacker's website on the link, that is attackersite.com. I send you the link, you click on the link. Now, when you click on the particular link, what happens is I have my own script that is that forms of the URL that will be found when you try searching for something in Facebook. So if you're trying to search for, let's say, if you're trying to search for the string ABCD in the search box in Facebook, for example, and you click OK, you'll be getting an entire URL with the word ABCD over there. Now, when you come and visit, when I make you lure, and when I lure you to click onto my come on and visit my site, an entire URL with the script that I have placed will be placed as a search request from your Facebook page. So instead of ABCD, you'll be having the entire script that goes, and that script will be my script. Now this script, it will have the capability to communicate back to attackersite.com. Although the script is being rendered and although it is being executed in context of Facebook.com, the script will still be able to contact and access attackersite.com because of the presence of on attackersite.com I have implemented cross-origin resource sharing. Now, in such a way, in such a situation, in such a scenario, what would happen is a tunnel would be formed, a communication channel will be established between the script that is running on Facebook.com and the user being unaware of it, and my attacker site. So from my attackersite.com, I can send in commands over this communication channel to my script, which can get executed. It will actually be an entire HTTP tunnel. So whatever request the user will be making on behalf of his browser session, that will be captured by my script and will be sent over to my server, to my attackersite.com. So this is what would happen in the entire reverse web shell. And there's a beautiful tool that can give you a demo of this, that can explain you about the entire reverse web shell and abuse of the CORS feature, the cross-origin resource sharing feature, if it is not implemented properly. And that particular tool is known as the shell of the future. And you can always go ahead and try out your hands at the shell of the future. So okay, before this